Imagine a region in space where gravity is so intense that nothing, not even light, can escape. This is a black hole. Black holes are not empty voids or portals, but incredibly dense objects formed from collapsed matter. They're invisible, yet their presence is revealed by the way they affect nearby stars and gas. We see stars orbiting invisible points and matter spiraling into darkness, vanishing forever. The concept of black holes emerged from Einstein's theory of general relativity, though even he doubted their existence at first. But the universe proved stranger than fiction. Observations confirmed these gravitational monsters are real. Black holes shape galaxies and challenge our understanding of physics. They're not just destructive, they're cosmic laboratories where the laws of nature are pushed to their limits. Join me as we explore how black holes are born, how they warp space-time, and what secrets they hold about our universe. Let's begin our journey.
The birth of a black hole.
Black holes are born from the deaths of massive stars, at least 20 times the mass of our sun. These giants burn through their fuel quickly, balancing gravity's inward pull with the outward push of nuclear fusion. When the fuel runs out, fusion stops, and gravity wins. The core collapses in a split second, triggering a supernova explosion that blasts the star's outer layers into space. This explosion creates the heavy elements that make up planets and life itself. If the remaining core is massive enough, it collapses beyond a neutron star, shrinking to a point of infinite density, a singularity. At this moment, a black hole is born. The event horizon forms, a boundary from which nothing can return. The black hole is the ghost of a once mighty star, now an invisible titan. These cosmic remnants are scattered across the universe, shaping galaxies and seeding the cosmos with the building blocks of life. From destruction comes creation. The cycle continues. Gravity isn't just a force, it's the warping of space-time itself, as Einstein revealed. Massive objects curve space-time and other objects follow these curves. Picture a bowling ball on a rubber sheet. It creates a dip, and marbles roll toward it. A black hole is like a pinhead so heavy it rips a hole straight through the sheet, a bottomless pit in space-time. Its gravity is so intense that not even light can escape once it crosses the event horizon. Light's path bends so much near a black hole that it's trapped forever. The escape velocity exceeds the speed of light, making escape impossible. Black holes are the ultimate expression of gravity's power. They show us just how strange and extreme the universe can be.
Event horizon and singularity.
Every black hole has two defining features: the event horizon and the singularity. These are not just abstract concepts, but the very heart of what makes a black hole so mysterious and fascinating. They represent the boundaries between what we can know and what lies forever hidden from us. The event horizon is an invisible boundary, the point of no return. It marks the edge of the black hole, a region in space where gravity is so strong that nothing, not even light, can escape its pull once crossed. Cross it, and escape becomes impossible, no matter how fast you travel. Even the fastest thing in the universe, light itself, cannot break free from the black hole's grasp once it passes this threshold. It's like the edge of a waterfall. Once you pass it, you're swept over, unable to turn back. The event horizon is a one-way door, sealing off whatever enters from the rest of the universe. At the center lies the singularity, a point where all the black hole's mass is crushed to infinite density. Here, the very fabric of space and time is warped beyond recognition, and the known laws of physics simply cease to function. Here, the laws of physics as we know them break down. Gravity becomes so intense that our current theories can't describe what happens, leaving us with more questions than answers. We can't truly visualize a singularity. It's a place where our understanding fails. No telescope or instrument can peer inside, and no signal can escape to tell us what's really there. The singularity is the final destination for anything that falls in: matter, light, even information. Everything is drawn inexorably toward this mysterious point, lost to the outside universe forever. Some physicists believe unlocking its secrets could unite gravity and quantum mechanics. If we could understand what happens at the singularity, we might finally bridge the gap between Einstein's theory of relativity and the strange world of quantum physics. For now, the singularity remains one of science's greatest mysteries. It's a puzzle at the heart of the universe, challenging our most fundamental ideas about space, time, and reality itself. The event horizon hides this enigma from the universe. It acts as a cosmic curtain, keeping the singularity's secrets locked away from prying eyes. Black holes challenge us to rethink the very fabric of reality. They force us to confront the limits of our knowledge and inspire us to push the boundaries of science. They're cosmic riddles, waiting to be solved. Each discovery brings us closer to understanding these extraordinary objects and the universe they inhabit, and they remind us how much we have yet to learn. The mysteries of black holes continue to captivate our imagination, urging us to keep exploring the unknown.
A familiar analogy.
To truly grasp the strange nature of black holes, let's start with a simple analogy. Imagine that space and time aren't separate things but are woven together into a single flexible fabric, what scientists call space-time. This fabric stretches across the universe, invisible yet fundamental, shaping everything we know. Now, picture placing a heavy object like a star onto this fabric. Just as a bowling ball makes a deep dent in a trampoline, massive objects create curves and dips in space-time. The heavier the object, the deeper the dent it makes. Smaller objects, like planets or marbles, roll toward these dips, following the curves created by the massive object. This is why planets orbit stars, and moons orbit planets. They're simply following the paths carved out by gravity's invisible hand. Gravity, then, isn't a mysterious force pulling objects together. Instead, it's the result of objects moving along the curves and warps in space-time. Even light, which travels incredibly fast, bends as it passes near massive objects. But a black hole is something far more extreme. Imagine not just a heavy ball but an infinitely sharp needle piercing the fabric, creating a bottomless funnel. The fabric doesn't just dip, it plunges downward, seemingly without end. Anything that crosses the edge of this funnel, the event horizon, can only fall deeper, unable to escape. Not even light can climb back out once it's crossed this invisible boundary. At the very center, the funnel's slope becomes infinitely steep, leading to what's called a singularity, a point where our understanding of physics breaks down. This warping doesn't just affect space, it stretches and twists time itself, making the flow of time behave in ways that seem impossible from our everyday experience. Near a black hole, time slows down dramatically, a phenomenon known as gravitational time dilation. The closer you get, the slower time moves for you compared to someone far away. To a distant observer, it would look as if time for someone falling in slows to a crawl, almost freezing at the event horizon, while the rest of the universe races on. Black holes don't just challenge our ideas about gravity, they stretch our understanding of both space and time, revealing the universe's most mind-bending secrets. They're not just objects floating in space, but powerful distortions in the very structure of the universe, twisting and shaping everything around them. In the end, black holes remind us that everything in the cosmos is connected, woven together by the fabric of space-time itself.
A journey into the maw.
What happens if you fall into a black hole? It depends on its size. In a small stellar mass black hole, tidal forces would stretch you into a thin strand, spaghettification, long before you reach the event horizon. In a supermassive black hole, the event horizon is gentler. You might cross it without noticing, but once inside, your fate is sealed. Every path leads to the singularity. Time and space become warped beyond recognition. For a brief moment, you'd witness the universe in ways no one else could, but ultimately, you'd meet the same end, crushed at the singularity, lost to the outside world. Black holes are the ultimate one-way trip.
Why black holes matter.
Black holes aren't just cosmic destroyers, they're architects of the universe. Nearly every large galaxy has a supermassive black hole at its center, shaping its evolution. As black holes feed, they release energy that regulates star formation and sculpts galaxies. When black holes merge, they send gravitational waves rippling across spacetime, signals we can now detect. These waves reveal secrets about gravity and the universe's most extreme events. Black holes recycle matter, distribute heavy elements, and drive cosmic change. They're natural laboratories for testing the limits of physics. By studying them, we push the boundaries of our knowledge. Black holes are keys to understanding the cosmos itself.
Famous black holes and their stories.
We know black holes exist thanks to decades of ingenious observation. For generations, astronomers have pushed the boundaries of technology and imagination, peering deeper into the cosmos to uncover these mysterious objects. Their existence was once only a bold prediction of Einstein's theory, but now, black holes are among the most fascinating realities in astrophysics. Cygnus X1, discovered in the 1960s, was the first strong black hole candidate, its unseen mass revealed by a companion star's orbit. This system became legendary, sparking debates and inspiring generations of scientists. The X-rays pouring from Cygnus X1 told us that something incredibly dense and powerful was lurking there, invisible to ordinary telescopes. At our galaxy's center lies Sagittarius A, changed our understanding of the Milky Way, revealing that black holes can anchor entire galaxies. In 2019, the Event Horizon Telescope captured the first direct image of a black hole's shadow in galaxy M87, a global scientific triumph. This iconic image, a glowing ring surrounding a dark core, offered visual proof of black holes and confirmed decades of theory. It was a moment that united scientists and the public in awe. Gravitational wave detectors like LIGO have heard black holes merging, opening a new window on the universe. These ripples in space-time caused by titanic collisions let us listen to cosmic events that were once silent and invisible. Each detection is a new chapter in the story of black holes. Each discovery tells a story of invisible giants, cosmic collisions, and the dynamic nature of our universe. Black holes shape galaxies, trigger bursts of energy, and even help create the elements that make up planets and life itself. Black holes are everywhere, shaping the cosmos in ways we're only beginning to understand. From the smallest stellar remnants to the largest supermassive giants, they influence the structure and fate of galaxies across the universe. They're not just theoretical, they're real, and their influence is profound. Their gravity warps space and time, distorts light, and can even tear apart entire stars that venture too close. Every new observation brings us closer to unraveling their mysteries. With each discovery, we learn more about the universe's most extreme environments and the fundamental laws that govern everything. Black holes are the universe's most compelling storytellers. Their existence challenges our understanding and inspires us to keep exploring the unknown, and their stories are far from over. As our tools and curiosity grow, so too will the incredible tales these cosmic enigmas have to share.
Key takeaways from our journey.
We've explored the birth, nature, and impact of black holes, cosmic objects where gravity reigns supreme. Black holes are not empty. They're dense, powerful, and mysterious. Born from dying stars, they seed the universe with elements and shape galaxies. The event horizon marks the point of no return, while the singularity challenges our understanding of physics. Black holes are not just destroyers, they're creators, regulators, and cosmic laboratories. By studying them, we learn about the universe's extremes and our own place within it. Black holes remind us that the cosmos is stranger and more wondrous than we can imagine.